going. So thanks very much for your time in the busy day. So today I kind of wanted to talk about the flakiness because as we know, like this is truly a universal problem, right? So if you look at I was looking at one of the article from Google in which they said like even for them, which we'd like to think they have a pretty high level of engineering standard, fully 1 in every 7 tests have some level of flakiness, which is a lot. So that just shows how universal this problem. But really, I don't think I don't think you need to be told that this is a universal problem. I mean, otherwise we probably aren't here. And I mean, every team I have involved in my entire professional career had struggle with some level of flakiness, some more serious than others. So I wanted to maybe like my most recent experience on this was in the Jenkins project. So the unit tests and so on, those were fine, but we had something like integration level testing that test Jenkins as a black box through the WebDriver. And as many of you can imagine, those had plenty of flakiness. And then, so that really kind of got in the way of people trusting that outcome and making that more regular part of the delivery pipeline. And I think those are the kind of the challenges you're probably feeling as well, right? That is to say, this like an alarm that like a misfires all the time is actually more like a useless, sometimes worse than not having it. It creates this crying wolf effect. People might be still willing to react for the first few times, but after a while they start to basically check that out. And they lose confidence to the overall, not just this particular test, but the overall system or the entire test suite, or sometimes to the whole process. And then that also translates to the loss of confidence to the people who are promoting these practices, like CI, CD, the DevOps, and more smooth, streamlined delivery process. That means like your credibility kind of gets damaged. And that in turn negatively impacts anything else that you might do. So I think for all these reasons, this is a pretty serious problem. So, I think if you've probably also been on the receiving end, the frustration on the receiving end, right? This is 5 p.m. and you need to land this change before close of business today so that you can communicate to the stakeholder. And then lo and behold, your pre-mortgage is failing because that one test is like a flaking again, right? And so you drive back and you log in back and you see the result, it has failed, and you schedule just a rerun, which means in another hour you need to check back in again and just make sure it went in. So like it's nothing is more frustrating than needing to come back to this like a late night reruns just to get the change land. For the then it's kind of struggling for the reasons that's not your fault. But at the same time, what makes this difficult is these flakiness could be actually a problem in the program being tested, right? Like unusual or rare race conditions that happens in some situations, like when the memory pressure is high, or like some cache eviction problem, which doesn't materialize, doesn't show up when you're running locally because your development machine is beefy, but when you run in a local resource constrained machine, it doesn't, or platform issues. Non-deterministic behavior. I'm sure we have all this experience, and it turns out that some of what I thought was a flaky test in Jenkins pipeline when I was implementing it, it turned out to be a race condition. So those problems, like we're always afraid of like letting these bugs slip through the door and into the production. So that makes this a real challenge. Now, the good news or the bad news is that everybody has this problem. And so, it's worthwhile looking at what other people are doing instead of trying to invent this on your own. So that's basically the whole purpose of this presentation. It's like, I don't really claim to have a magical answer, but in comprehensively looking at what the different teams and also most publicly talking about these things and privately, I felt like I learned a lot about this. So this is my attempt to kind of output that and help you see kind of see through this in a certain framework. So, so it always helps to know your enemy, and when it's kind of so this data comes from, I think it's Google, I believe it's Google. So, and then they sort of quantified what we instinctively knew. Like, in other words, like we knew that the flakiness tends to correlate with the, this test that spans the large thing. So they sort of map the memory consumption of the program versus the test, and you can see a very clear correlation between the high level of flakiness and the test that occupies a large memory. So again, it's not a news, but I think as that you can do a quantification is great. You see this like exactly what the slope of the curve is. The other interesting discoveries, and this I never actually had a personal experience, is there are some class of flakiness that arises from the time-related issues. So I guess if some people are showing, the data in the handling the time and calendar in the UI, and you're testing those, I suppose that's when they happen. So like, the flakiness, the test failure that only occurs at the last, day of the month, or when in the February, or that sort of things. And then probably another more famous kind is like the dependency to the global state. And so when the previous test leaves the system state into some, fail to clean up its act behind, then the next test could interfere. So, those are, this I can resonate more, and multiple teams have sort of reported this problem. I think, let's see, I think in this case, they came from, well, I guess my left note doesn't show. Another thing that's also reported by multiple teams, the Google and GitHub specifically, is that, the flakiness is not evenly distributed. In other words, like, if you're not measuring this carefully, like it's maybe I'm just speaking for myself, like my mental framing is very simple. Like a test is either flaky or not, right? So it's binary. But what these guys have found that it's actually not. It's like a sliding scale. So Google, as I mentioned in the number earlier, they found on one hand, 1 in 7 tests have some level of flakiness. But at the same time, only like 1.5% of the test runs are flaky. So that's a lot less than 1 in 7. And what that means is, when they say 1 in 7 tests have some flakiness, vast majority of these tests are not all that flaky. Right? And then GitHub, they look at this in a different way. So for any given time span, they said, okay, how many occasions of flakiness did a test exhibit? So they said like more than 20. I think the 24% of the tests have flaked at least once in this time span. So that's actually worse than Google number, but not too much. But they also saw that there's 0.4% of the tests that exhibited more than 100 times of the flakiness. So what that gives us a little bit of comfort that if you can direct your effort well, that instead of focusing on all the 24% of the test, if you can just focus on this 0.4%, then either throw them away or make a fix or something, then the total number of incidents or disruption to the pipeline that comes from flakiness is really, it can make a significant impact. So I believe that's exactly what GitHub did, and they reported the flakiness reduced by 17 times. So basically, reduce the problem into the 6% or something like that. So 94% reduction in flakiness by just basically focusing on 0.4%. So that's amazing. I think it speaks to the importance of actually measuring it. So that's the kind of, okay, so that's a little bit about the enemy, what we know about the enemy. So what have people done to slay this monster, right? And as I mentioned, there's a lot. I mean, just if you just look at what's publicly talked about, there's plenty of articles from a who's who of the engineering organizations. And I've been in the fortunate position to talk to a lot of different development teams offline and in private, and I know many of them do some different level of sophistications, or I mean, let's face it, not everybody can throw like a Google level engineering into just fixing fakeness, right? So, but in some sense, I think those are sometimes more useful, like things to learn. Like, these are your neighbors, right? Like, you might not be able to do what Google is doing, or not, nor does it make sense to do so. But if you can think about other comparable teams and see what they have done successfully, well, that seems like a pretty good indication, isn't it? So, when I look at, sorry, did it go back? So when I look at the so these are all the so just to kind of list some of the publicly posted articles. These are those, and when I look at these and like I think about what I've seen, like the picture started to emerge in my head that this like attacking flakiness really needs to there's a combination of these three pieces, three pillars, and I call the first one the keeping the build green. In other words, the idea is like accept that some level of flakiness exists. Some people actually doesn't seem to be capable of accepting that, but it is what it is. And then try to reduce the disruption that comes from that into the delivery process. So keeping the delivery process running and humming, even in the presence of some noise like flakiness, right? So I call that keeping build green. Now, one of the downside of keeping build green is that it also works to sort of suppress or hide the flakiness problem. So to counter that and also to correctly focus the effort, a lot of people spend effort measuring the flakiness. And I think you can also instinctively see the value of it. So there's a whole bunch of effort done in this space. And now that you have measured the flakiness and you kind of kept it hidden from the eye of the developers, the third pillar is like, at some point you got to do something about it. And so I call that escalating flakyness to the developers. So there are, again, like all these teams, I show the numbers in which it's not possible or practical or wise to work on all the flakiness. Right? So the idea is like which ones like need work and try to collect enough intelligence so that the humans can act on this more effectively. And then so that's the last bit about the escalating flakiness to the developer. So in some sense, like they're putting the system as a frontline defense for flakiness. And for the ones that really the problem is outrageous, then it kind of gets the attention of the developer. So that's the scheme, right? So let's look at what people have been doing in these different pillars. So the first one is the keeping build green. So as you can probably guess, like probably the most naive and widespread practice is basically retry the flaky test until it passes. And you can see this in pretty much every test runner. So, here's Gradle, Maven. I mean, this is a very, very universal features. But it's also interesting that the people don't always do this at this like a microscopic test runner level. So the Maven and Gradle ones, those are like when the moment, like a millisecond after a test fails, they basically run it. Right, so the usual, like a scheme is like a run it up to, n times if it keeps failing. But here, like you see, somebody did the same thing for Jenkins, which is like a happened much later. So the whole test suite runs, and only after that, like somebody in this scheme, they would come in, developer would come in and ask the failed test to get rerun. So that's a bigger loop. So I'm trying to make the distinction between like this, like a small loop to rerun versus like a bigger loop to rerun. So why is that? So it turns out that there are the good reasons, because not all retries are equal. So a number of people. Well, again, this kind of perhaps makes sense intuitively, like as a human being, like if something failed on this computer on this time. Well, maybe if you try it on another computer on another time, it's like a different IP address or whatever. Like it might, it just might pass, right? So that's like a naive version of it. But the more sophisticated teams have reported there's actually more than just that naive assumption. So the GitHub and Dropbox both reported that there's like a time-sensitive, calendar-sensitive type of flakiness. So they developed this practice of rerunning tests by shifting the testing to the future. So just they force the system clock to be set to different time and rerun the test in the hope that it will pass. Or the GitHub came up with this, just rerunning this in a different VM. So that's just maybe another variant of like wishing for the luck just by creating a fresh new environment. So it turned out that this kind of like a multiple layers of rerun loop was necessary. Now, the part of what goes in my head when I hear this is like, how does this, some of these things could be pretty transparent to the developers, which is good because the whole purpose is to not introduce too many noise, but some of them could be pretty disruptive. So like in this Jenkins-based rerun thing, it's a human would have to come in to do so. So I feel like a lot of teams still struggle to keep this kind of large loop automated and invisible to developers. Now, the VRAMs is also not free. So the problem, I already talked about, how it also masks the problems. And when I talk to, people, or when I see when I talk to engineers who just refuse to, refuse to keep builds green, the number one argument that they raise is, well, like, it's going to mask the problem. Like people will start ignoring those, paying less attention. But that's actually only true if you're not measuring them separately. So that's kind of goes back to my argument that you need to hit those three pillars all at the same time. But another real problem of the retries is that it actually delays the feedback, because when a legitimate failure happens, it also gets retried for up to n times, easily like 5 or 10. And this number of retries just tend to get like, there's no incentive to shrink it down for the most of the time. So when there's like at the moment of heat, when you need to just ram this like a hot fix in and that flaky test is misbehaving again, then people will just like bump up the retry counts in the hope that would, solve the problem and let them get the change in. So it keeps like, growing. So this delay to the feedback cycle kind of goes up over and over, and that's a real problem. Now, but retry is not the only thing people are doing. So that's, I think, is worth talking about. It turns out that ignoring flaky tests altogether, sometimes not even running them, sometimes run them, but like not let the failure status mark the overall build, red, is also a practice that exercised in different teams. So, Dropbox and Google both talk about doing just that. They essentially tag the test as flaky, basically automatically from the system. And then different parts of the delivery pipeline, especially the pre-merge, stop running these tests or start ignoring these results, so that the developer's change can land. And later in the delivery pipeline, when the things are more under the control of the DevOps people, they might choose to run the flakiness, or maybe in a different place or at the different frequencies, so that so that they can keep an eye on like how things are moving there. So that was an interesting discovery for me. And if you're DevOps engineers in the feeling like, I can't, in some sense, like your struggle is self-made, right? Like you don't want to like ignore this flaky test, but you also want to reduce the noise that's coming from it. Then know that some other people have actually, like they disabled this test, and that was acceptable. And there's clearly this like psychological barrier to ignoring the flaky test. So again, that's a theme that happens over and over in talking to teams, looking at the commentaries in Hacker News, talking to other devs. So then I sort of sympathize that on one hand, like putting the developer closer to the fire and make sure that they keep this flakiness in check. But it also know that you're also doing it at the by risking your own credibility. Like you can only if turning up the heat is all it takes to get the problem resolved, then I can tell you that the management job is a whole lot easier, or like a parenting is a whole lot easier. And we all know that it just doesn't work like that, right? So it kind of needs to be careful here. And then the most persuasive argument, like, summarize condensation of this feeling that I saw I think this was in the Dropbox post, was like, they were saying, well, we are not going to let Bob penalize for the flakiness that Alice has introduced. Like, we are not collectively punishing the whole team just because like one guy, one person made an honest mistake. So I'm really curious, like, how do you feel about it? And like, I'd like to hear your thoughts in this like a flakiness webinar, the Discord channel, if you care to share your feeling. I'm sure you have opinions developed over your professional careers. But I'm going to move on in this presentation. So let's talk about the next period, measuring flakiness. So the baseline that what the most people are doing is what I can only describe as a tribal knowledge. Like senior developers, the people who have been with the project long enough, kind of knows that these are flaky tests. Rather than we see some failure mode, they just know that, okay, that's just flakiness. I've seen that before. Right? So there's no science in it, but it's so no effort necessary. Human does a pattern matching, and the quality of that pattern matching might not be great, but that's basically what people are doing. So how they up the game from there. So the baseline calculations, then the next step is actually try to calculate, put some number to this. And by far, and the majority of people, what they do is to count the number of like different outcomes that came from a same commit. Right? So if you test the same commit and the test behaved in two different ways, then you kind of mark that as an incident of flakiness. So everybody seems to be doing that. Launchable, this was like how we calculated our flakiness in our current product that we offer. And I've seen some, the internal spreadsheet and like Elasticsearch query that the people have created in-house, and all sorts of things in which people like over and over recalculated this kind of index. So it's a safe bet. But we also all know that there's a shortcoming in this, which is, often, I don't know, maybe I shouldn't say often, but we know that sometimes, the test fails because of, let's say, failed external dependency. And then the reason the test gets rerun is because somebody can out of band worked on that, the external dependencies and fix things up. So those are not the flakiness. Those are just like, caused by the legitimate state of the world. But so in this naive approach, you could easily miscount those, like, mix them up. So that's so people who kind of move beyond that. So the state of art is that the one that I thought was really clever was from the Spotify engineering blog, in which they said, they look at the correlation between multiple other failures. So in this chart, let's see, I should be able to, okay. So in this chart, so they're probably, so this like a rows represent the different test case, and column represent different test executions. So when you see something like this, where like suddenly lots of tests fail together, then that's, they claim that that's more likely caused by the, the external dependencies rather than fakeness, which, it makes intuitive sense. Whereas like these guys, like one-off failures and so on, like they are more likely flakiness. So they kind of use that. I don't know exactly how they compute that, but factor that in. So that that I thought is a really simple but still seemingly clever, effective approach. Another one that I saw was from the Facebook, and this I can clearly see some like a PhD math guy came in and like decided to stretch his muscle a little. So they essentially model, like create this mathematical model of what's causing the flakiness. So when they run the test run, there's some probability that the code is bad and that results in flakiness. But even when the code is good, like there's a test, let's assume that the test has an inherent level of probability of flakiness. And if you hit that, then the test also fail. But this time, because of flakiness, Now, if you run this often enough, like you cannot really, from the observation, you cannot tell those two kind of failure apart. But you can sort of by using the process called Bayesian inference. It's not that hard of a math, really, though very clever. Like you can try to estimate the combination of this, probability of the bad code versus probability of the failure. So based on the observations, they kind of reverse engineer that into say, so in this case, the PF is pretty high. So it's like a peak is around 0.20%. And the probability that the bad code created this kind of distribution is 0.05. So that allows them to not only quantitatively say how likely this is to be a flaky test. And if a developer is looking at this outcome, so they have test runs. And so what this means, they have 3 tests against the same commit, and that time all 3 failed, and then other times 2 failed, 1 passed. This, if I'm looking at this, I would say, yeah, this kind of looks like, start to look like flakiness. So they can, the mask can probably correctly check that out. So those are a really clever approach. So 2 of the more sophisticated way people are measuring the flakiness. All right, so let's move on to the 3rd pillar, so the escalating flakiness. So when the flakiness, when you start, let's say, running this the flaky test, and how do you escalate the flakiness? So so that you get the attention of the developers. So the naive solutions, I think, what the people are doing is, create, organize the, I don't know, fix the flakiness week, or there's some, things get bad enough, somebody, maybe architects or a senior engineer convinces the managers that we need to spend some people in this engineering cycle to work on the flakiness. And then that's kind of how to go about it. But beyond that, what's being done is, well, actually, so basically that basically amounts to creating a ticket to investigate. Then either you fix it, or you accept that this is just unfixable and delete those. So but that's, people seems to be, I guess, so actually what I wanted to go with this picture was deleting a test, just accepting, sometimes accepting that this just isn't testable well in scripted automated manner. Accept that defeat and deleting a test should be a viable option, at least sometime. Right? That way you can reduce the, you can reduce the noise. But I felt like anecdotally, I feel like people and developers seems to be extremely hesitant to do it. And then I wonder what the psychology that kind of plays into that. Are they underestimating the a negative impact of the flakiness, or are they overestimating the value of a test, a single test, right? How useful can that be? So I don't, there's some clearly a recognizable behavior in developers that I can't quite put the finger on why do they do it. But anyhow, that's I think what the people are generally doing, or a very organic human-driven approach. Now, some of the companies did some pretty sophisticated stuff here, which I wanted to talk about. So this is GitHub. So they have this system that collects a lot of information about the flaky test and then escalate that to developers. So this one is currently marked as unresolved, meaning that is the state of escalation, right? And then they said, they have a fancy things like an impact score, and it's been seen for so many days, and based on the behavior that, hey, I guess this test, this flaky test tends to run successfully if they rerun the test in the different clock times. So I guess based on that, they differ for information this must be a time-based test. And instruction to run the test for developers, and they even try to track down who might be the offender of this very fancy Well, Google and Dropbox also talks about the similar systems, although they don't share the screenshots. And then, so when I was looking at this, I kind of, well, actually, I'll come back to that later. Another one that I thought was really clever is this, will show up in the Dropbox description. So they have a system that's basically running tests on all the time, all over. And then when they notice that the test is exhibiting some like a noisy behavior, like a test is fading or seen passing, then instead of like just flagging it, they start this automated, what I can think of as a triage process. So they just, for example, like start aggressively running this test, even sometimes going back to the previously successful test to see if you can make the successful test flip to a failure. Then that's a good good indication that it is a flaky test and not because of the code failure. So that also makes sense. So as they start running this sequence of automated activities to try to automatically determine if it's because the code was bad, in which case it looks like they yanked the change out from the pre-merge queue, which makes sense. Or like they say they determine that the system is preliminarily determined that a test is flaky, and then the test gets kind of quarantined, meaning the test gets pulled out and then marked as a human intervention necessary. So that's kind of acting as a triage systems. And I've seen this kind of like a triage system in a lot of places, and that can get also pretty fancy pretty quickly. People running like automatic Git bisecting to try to pin down the exact failures, combined with like rerun behaviors. So all sorts of clever things have been done, but not in many places. Building this kind of system requires a pretty high, engineering effort. But some do, which kind of shows the extent of this problem. Now, as I was reading those things, like the question keep popping up in my head is, some engineering teams spent these extraordinary lengths to try to make a convincing argument that this test is flaky, and then so it makes me wonder, so what for? Right? So in other words, like are those data making changing the developer behavior compared to not having this data? Right? So maybe all this data helping developers to take different actions, or quarantine test, they call quarantine. If the test gets pulled out, it's almost effectively like getting deleted, right? Like it stopped getting used. I mean, it's still in the Git repository and you can run it, but for all intents and purposes, the test was deleted. So maybe if people are like not acting enough on these escalated flaky tests, and when I as a developer, I know like fixing flaky test is hard at best. I mean, sometimes it's just downright impossible. So if I'm not gonna be able to like fix it anyhow, and just like basically keep that in the quarantine state forever, is it just like a more fancy way of like deleting, but without like a triggering my guilty feeling that I'm like triggering this psychological barrier, trip barrier that you can delete the test. No, like that's unacceptable. So maybe it's just working for that, or maybe like how much of that is actually helping developers actively do a better detective work. I mean, if you look at some of the GitHub thing I just showed you earlier, some of that does seem to legitimately help, developers work on this. But like how many of these flakiness can be like neatly categorized like that? I have my own doubts. So yeah, like I'm really curious. Like I talk to people a lot where they feel like this building a system like that they're convinced that would help. But like at the end of the day, if the developers don't really do anything with this output from the system, or if it doesn't change the behaviors, and it's not really making a real impact, in my opinion. So I am just very curious about that. Again, this is something else I'd love to hear, your thoughts if you have. Happy to take that in the Discord. And then it's also worth mentioning that outside these three pillars, there are like some entirely out of the box approach, which I actually really liked. So then that is to say, like a re-architecture of the product itself to be fundamentally more testable. And this seems like basically the whole point of blending the barrier, and removing the barrier between the quality and the development, right? It used to be those are like a separate function with like almost like some wall between them, intentionally designed to keep each other in check kind of mindset. But now like more teams, less teams are organized like that. So the point of that is like engineers take really testability into the heart and into the way they write software itself. So the Airbnb has this awesome post about how they introduced a new framework. Again, like, you sometimes just wonder, like, how many engineers are like lying around in this company, like, your job is to put people into the house and give vacation, and some of their engineers are building like a mobile web app development framework. Like it makes you wonder if that's the best use of their time. But anyhow, so they did this like MVRX framework, so they had a number of goals, but the one of it is to create more like a fundamentally testable web app, the mobile application. So this kind of feels like a React-ish, but they have a single immutable state class that represents carries the entire data that drives the screen. And then there is this like from somebody from the web layer, what I can only think of as a controller layer. So that takes this data and figure out like figure out this UI components to show them. And then the layer that maps those things. So what that allows them to do is like, they can mock any state in any part of the applications and then like turn that into the UI and then render that in the screen. So even when they have like a lengthy, complicated modal flow or some like, UI flow that only gets triggered in case of errors, like they don't have to go through the human interaction, simulate the human interactions like WebDriver and Appium would do, but just can just like individually test those different pieces separately, which makes it a lot easier, and also by doing so eliminate like a lot of the source of the flakiness. So they clearly state that one of the motivation for doing this framework is to make the test more reliable. So I thought that's a great engineering mindset at work, right? I mean, not like you don't rely on like you think about the systematic way to crash the whole class of a program, like make it a part of the design. So I think they clearly succeeded in that. So that's great. And I'm more old school, like a Java web app kind of guy. So they're like, at one point, one of the whole argument behind the inversion of control frameworks like Spring and so on was the testability. So that was another example in which like we can eliminate like cutting out a lot of big pieces like database access and external systems, and then replace that with a mock to make sure things are testable. So that's the more architecture approach. So I think that's also worth mentioning. So as I guess time starts to run to the latter half of the hour. So I know. So what these sophisticated engineering teams talk about are great, but my perception of talking to the real world software development teams is like there's a lot of distance between where you are versus what these guys are. And but then that makes sense, and that's how it should be. So how do you go from where you are from here to there? So when I look at, again, like the picture that kind of I get is there's one sort of a key capability from your test QA system that is necessary to, kind of enable all these three pillars basically. And that is to be able to, run arbitrary tests against the arbitrary software under test, meaning the software you're testing as quickly as possible in many different setups. So, in more naive delivery pipeline, I'm used to people seeing it as a single sequential process. And where you build the source code and you compile the test and then you run all the tests. Sometimes those things are intermixed together and not easily separable. Right? So that's the counter example of being able to run arbitrary tests against arbitrary subject on the test rapidly. Sometimes you can't even rerun the test without recompiling the source code. So all of these teams and all of these practices kind of require having this capability of choosing a smaller subset of a test and be able to run rapidly. That requires you to be able to rebuild the binary integration, for example, is a key piece of the practice. So this to get to this point requires a lot of work on its own. But I think that is actually a key capability, and that needs to be built. Because often in most places I've seen the test pipeline is essentially hand-rolled. And then sometimes where they're a little better than what I just described, the control logic, like let's say the driving where the tests are run against what code, it's so intertwined with how you run the test, like it's inseparable. A good example is like some hard-coded parallelization, right? You have a Jenkins pipeline code that comes to at some point and then just split into 3 ways and run like a 3 subset of the test, which is, I can see how people end up in that state, but that is an example, like a control logic, meaning the logic deciding this test runs there, like a decouple, intertwined with the actual ability to run code. So I think what the proper architecture to solve this is more like, I guess, a quote unquote, the cloud native fungible function of the service kind of thing, where you have this elastic compute pool that, that army of fungible test runners, if you may, just call it Kubernetes, and then be able to run the test, schedule the test here and there, and then not to worry too much about where they are run and be able to collect the results. With supporting infrastructure like caching and all that is necessary. But I think so the good news is it's generally consistent with the architecture that the software development itself is heading, but this is also relevant in the world of the sophisticated testing and flakiness. And then there's this whole idea around what I think of as the brain, the eyes and brain, that is to see what's going on with all these test outcomes and deciding what test needs to be run against what test, and how to interpret all these results to determine the flakiness, or to decide that this particular primordial should be allowed or not, or what test should be escalated into developers. And when I see this sophisticated level, that these things sophisticated statistical treatment that these things require, and also how far away these things are from what your main business is, I feel like this is the thing that we can, we the industry, I guess, can use. And so long as we separate that away from actual test execution capability, it is inherently tied to the kind of software you're getting developed. I feel like that would be a good general purpose versus specialized separation. So I call that as a buy versus build. I'm not trying to sell you a particular solution here, but that just trying to contrast that. So this is, naturally, where my current interest is, as a guy who is always interested in building a general purpose solution. So that's where Launchable is working on. But I know we are not alone in that. So that's kind of how I see this world. That brings me to the end of the presentation. So anything, any questions, thoughts, opinions? Love to hear, or calling out my bullshit if you feel it that way. And I'm happy to take the questions in webinar, ideally. I'm sorry, the Discord channel.
I am monitoring the Q&A, the chat, and the Discord
Yeah.
channel. No questions thus far.
All right. Well, let's see. Okay, so what do I think of JDK 17? All right, I appreciate you're asking questions, even though I don't see particularly. I mean so yeah, so I mean, as a long-time Java fan, I'm excited about the new version of Java. There are some nice language features that's in, and so I'm certainly looking forward to use it. But at the same time, I feel like my hands are tied. Like because the frameworks that I depend on them, like in my case, like the Apache Spark and the EMR, they need to upgrade. So I kind of surprisingly, I don't think I can use it anytime soon, and that's unfortunate. So I hope other people will have a better time. Yeah. So, but I also, or maybe there's something licensing related, the kind of things around the JDK 17, and so I hope it gets. Yeah, it was unfortunate when like Oracle kind of came across. I don't think they actually meant it, or I don't think the license term actually said it, but using Java in production needs to, needs payment to Oracle. And that was a major fiasco. So it looks like they kind of cleared it up in this round. So I applaud them for doing that. All right, that should be enough for JDK 17. Yeah, all right. So
it's like Aaron asked a question in Discord.
Yeah, so do you have any good data on incidence of test flakiness by the test pyramid level? He guessed most unit tests don't have this problem, but the integration tests do. Yeah, so I think everyone instinctively feels that way, and to the extent that I can find, I bring that data up in the earlier slide. The Google guys was the only one that I know who published actual data from this front. So they look at the number of correlating. So their challenge, I think the Google's challenge is like they don't have this like a clear boundary between unit tests versus integration tests. Like they have, well, to the extent that I work there, so but to the extent that I understand, they have a single all-encompassing build and testing system, Bazel or like a Blaze, and then every test is just basically in that mix. So when they analyze that data, they couldn't. No, actually, I'm sorry. I take that back. So if you see this, where do your tests come from? They look at correlation between the unit tests, integration tests, etc. Those are like a manually attached label by the developer, so it might be less trustworthy, but they see a clear correlation. They also see a clear correlation is the test, size of the runtime footprint of the test or the executable size of the test. So all the indications that they are unsuspected are there. They also look at, they also report that the test using WebDriver is also highly correlated with the flakiness. And no surprise qualitatively, but quantitatively knowing that factor is good. But sort of where this analysis kind of gets hit the brick wall in my mind is like the correlation isn't a causation. So, okay, so, people are not using, well, if you're using WebDriver to test 1 + 1 = 2, that's probably like a mistake. But, it's most of the time you use WebDriver because the thing you're trying to test requires that. So it's not like, it doesn't mean like if you replace WebDriver with something else, does that get better? Like they can't say that. So that I think is the challenge. So yeah, that's how I took it. And I think their post also talks about that as well. So I encourage you to look at this post. happy to. I suspect the slide is going to go out as a thank you email to everyone who attended. So you can click these links later to get the article. All right. Thanks for that. I think. If nothing else, then I guess that will be the end of the presentation, I think. So have a wonderful rest of the day and week. And as you can see, I'm very interested in kind of looking into this space. So if you have some thoughts, ideas, especially the ones that differ from my view, I love to talk to you, and you know where to find me. So let me know. I love to have your conversation. So drop me a note, and we will talk. All right. Thank you very much. Bye.